Hello everyone. Have a good day. We are Group 8 with the experiment 4 in minor loss in BABE. The group members is Abdurrahman Hassan Abdullahi and Al-Nawf Al-Nimraq Layth Al-Ahmed and I, Abdulmajid Gilawi, will have today the experiment 4 in minor losses in BABE. So abstract. The goal of this experiment is to determine BEP in situation where the minor loss is about to lose coefficient and minor hair loss through sudden enlargement into contraction elbows and pipe ends and pipe branches will be measured for every tested pipe section. Time taken to collect 3 liters of volume of water at the tank is recorded to obtain the actual flow rate. The value of loss of coefficient is influenced by water flow rates, pipe diameters, and pipe ends. And the main objective of this experiment is the aim of this to find out the loss coefficient value and minor heat loss in pipe components for different water flow rates of pipe diameters and pipe ends. And the introduction is the minor loss occurs at any location in a pipe system where streamlines are not straight. For example, pipe ends, valve sections, expansions, and contraction in this avoid inlets and outlets. The value of loss coefficient strongly depends on the type of fitting geometry of flow rates. The accurate coefficient value is required to predict the heat loss in the pipe system when the loss component is available. The heat loss can be determined.
Hi everyone, I am Al-Nawf Al-Nimraq Layth Ahmed from Group 8. I'm gonna present theory. The flow and piping system at different flow rates may be required to pass through a variety of fittings, bends, or abrupt change in Area 1. Additional head losses called as minor head loss are encountered primarily as a result of flow separation. By simplifying the Bernoulli equation between the 2 points for the horizontal Z1 and Z2 the pipe, the pressure loss and total head loss. In this experiment, minor losses at sudden enlargement, contraction, and losses at elbow band of pipe will be determined. Now is methodology. Apparatus, pressure management test bench as depicted in figure 3. As you can see, inlet valve, 2 table manometer turtle, test pump section, outlet valve. The procedure of this experiment: first, determine the duration of water inflow and outflow for the test pipe section. 2. Full open inlet valve by turning it to anticlockwise direction of test pipe section and close the inlet valve by turning it clockwise direction for in test pipe section. 3. Turn on the pump and slowly open the outlet valve by turning it to anti-clockwise direction until maximum full open, and wait for a hole in order to remove any air bubbles for the tested pipe section. 4. Identify the inlet valve pressure H1 and the outlet flowing pressure H2 for the test pipe section, and connect the manometer tops from those H1 and H2 of the test pipe section to the two top manometer H1 inlet and H2 outlet. 5. Record the values of H1 and H2 at two top manometer. 6. Determine the actual water flow rate by recording the time taken to collect the 3 layers full volume of water at the tank. 7. Reduce the opening of outlet value and report steps 4 and 5 for 5 different values of O arced. 8. After finished, remove the manometer tops first to avoid the bubbles in the top. 9. With Bob running recording, repeat step 1 to 7 for the other test pipe section. 10. After finished, remove all the manometer tops from the system. Full close the inlet and outlet value and turn off the pump and the main switch. That's all from me. Thank you.
Hello, Abdurrahman presenting the result. For the first table, we have the data for the sudden enlargement and a sudden contraction. We have calculated for Q actual and delta H. Next is a table for data of different primes, Y type and T type. We did the same and calculated the Q actual and delta H. Data for the pipe elbows is the next, which we calculated Q actual and Q and delta H as well. In the discussion, as you can see in the table, we combined all the different types of pipes and calculated for the loss coefficient and the head loss, minor head loss. For sudden enlargement, we calculated area 1, area 2, and then find the loss coefficient, minor head loss, friction factor, and we did the rest, and we did the same for the rest. Next, we need to compare those values with the theoretical values. For YT table, as we have seen, we found the loss coefficients to be 2, and precisely if we take the data from the manual, we can also get 2. And for 90-degree angle bend, and we can find the K from the table, 45 angle as well. So last part is discussing the effect of fluid velocity, pipe roughness, and pipe diameter on the value of loss coefficient and hence friction loss in the pipe. And as you can see, we have this equation, and based on this equation, the fluid velocity is directly proportional to the value of the loss coefficient. As well, the pipe diameter is inversely proportional to the value of loss coefficient. We can conclude that increased fluid velocity causes increase in the value of loss coefficient, which in turn results in increase in the friction loss in pipes. And also, when the pipe roughness is increased, the value of loss coefficient will also increase, and it will result the same thing, which is the friction loss in the pipes. When we talk about the pipe diameter, we know that it is inversely proportional to the value of loss of coefficient. So we can conclude from that if we increase the pipe diameter, it reduces the value of loss coefficient, which in turn results lower in friction loss in pipes. In part D, we will look together several factors that contribute to inaccuracy in experimental data. First of all, we have human error. We have leakage of water from pop or connection paths, we have parallax error, presence of air bubbles. So in order to eliminate those problems, we suggest several procedures to take in place. One of them is to look perpendicular to the scale of the mensicas, and as well as making sure all the connections are tight to prevent leakage. Leak test. We can also use leak test by using high pressure before the experiment. When it comes about bubbles present or left in the apparatus, we can double check that there's no air bubbles left inside the tube and apparatus. We can make sure that the outlet is fully opened. And to eliminate human errors, we can repeat the experiment at least twice for each of the readings.
As a conclusion, the flow in PAPE system is affected by a minor heat loss affects the flow in PAPE system at different flow rates to best storage, a variety of fitting pendants and abrupt changes in an area. The objective of this experiment was achieved in determining the loss of coefficient and minor loss in pipe component for different flow rates, pipe diameters, and pipe pendants. This experiment involves with some errors which affected accuracy of the result. Hence, some recommenders are in order to get more accurate during the handling of this experiment. So that is all about. Thank you very much.